All right. Good morning, everyone. It's Thursday, April 23rd. Hope you're all doing well. Hope you're all safe and healthy, you and your families. I just wanted to thank the people who attended our last Zoom meeting on Tuesday. If you didn't, please join us. We'll do it again on Tuesday again, next Tuesday at 1 p.m. That's the time our class meets. So we have to meet around that time and not any earlier or later. So hopefully you can make it. And if you can't, email me, get in touch. I just want to know how you are and if you're doing well, and if you have any questions about the class or anything else. All right. Miss you guys, miss all of you. Okay, so we're going to continue our lesson about factors on Earth that affect climate and temperature. All right. Just a quick review. Last week we spoke about, or last lesson we spoke about trade winds. We built onto differential heating on Earth, the fact that the center of the Earth is more heated than the poles, or as you go away from the center of the Earth, temperature drops, or the exposure to sun drops because this Earth is curved. Right, so less sun as you go up north, you go down south, more sun in the middle. And because of that, you have the hottest parts of the Earth are on the equator or close to the equator. And because we also have bodies of water around the equator, the water gets heated and you have evaporation happening because of the heated water. And as the water turns into vapor, it's lifted into the air, and because hotter air is less dense, it creates an area of low pressure, and the water vapor, the water particles rise up with the air, and therefore you have formation of clouds around the equator. And so a lot of the areas around the equator are tropical because first they're humid, so lots of water in the air, and then second, they're warm, right? Warm and humid gives you tropical areas, right? So why is it that the air comes down from 30 degrees north, 30 degrees south, kind of turns this way, right? Clockwise in the northern hemisphere, counterclockwise in the southern hemisphere. Why is it that the wind patterns do that? And obviously the warm air ascending or lifting up creates the clouds. Now the answer to why that happens is something called the Coriolis effect. Okay, the reason the winds are, first of all, traveling from east to west, and second, they're kind of doing this pattern of clockwise and counterclockwise. All right, so we're going to talk about that today. Again, it's called the Coriolis effect. Okay, and just to give you another bit of review, the trade winds, which are these winds that we name from 30 degrees north, traveling to the equator, and also from 30 degrees south, traveling to the equator, going from east to west. We name these winds the trade winds, right? And they got their name mainly because when humans started exploring the earth, they went from east to west, right? So they traded, they hopped on their sail ships and sailed the wind from east to west. Okay, so these winds are affected. The reason they're going in this pattern is something again called the Coriolis effect. And the Coriolis effect is the result of the spinning of the earth from east to west, okay, because the earth spins on its own axis. You have this rotary effect on the surface of the earth because it's spinning, right? So in a nutshell, basically, because it's spinning in this direction, right, from going from east to west, it's spinning. If you are anywhere on the northern hemisphere, actually, first, before we do that, towards the center towards the equator, because it's the Earth is round, right? The equator, because it has more mass, it's a bigger area, it actually spins faster. The Earth spins faster towards the equator than it does towards the poles, right? So if you were in the northern hemisphere and you throw something, it will actually travel. It'll go farther to to a place that's more east of you, okay, and then opposite direction there, right? Because the center is spinning faster. So if you're up here, you throw something straight, it actually will take a curve. It'll curve because again the center is spinning faster. So if you were down here throwing something up there, it would actually end up further to the east, further to the west than where you are standing, because of the fact that the earth spins on its axis, and because the center is kind of spinning faster than the poles, right? So this effect, this Coriolis effect, creates these patterns of spinning, not just wind, but also water. Okay, and we'll talk about that later. Okay, so because of that, you have these the Coriolis effect affecting the trade winds from from 30 degrees north and south to 0 degrees, which is the equator. Okay, so for today, all you have to do is work on the summary, fill in the blanks. The Coriolis effect results in the movement of air and water in a, what kind of direction is that in the northern hemisphere, right? Kind of maybe how you tell time. And then the opposite of that in the southern hemisphere, right? And then the Coriolis effect as a result of the Earth's, how is the Earth rotating? Okay, so just about 4 words and quick, easy lesson today. Okay, hopefully it made sense. If it didn't, please ask questions. I'm sure I may have confused some of you with this drawing right here. But again, because of the Earth's rotation from east to west, and the fact that the Earth is a sphere, right, a globe, things, basically the Earth spins faster around its axis than it does around its poles. Okay, please ask questions if you need. Otherwise, I will see you hopefully on Tuesday.